Hi, this is Kevin Leach from InQuality. We're looking today at USB microphones and audio interfaces, how they work with ipDTL. We'll try an ISDN call from ipDTL to this Telos ISDN codec, and we'll also open this box which contains the new Rode NT USB microphone. Let's start with this Focusrite Scarlett 2i2 USB interface. It's what we tend to recommend to voice talent and studios who need to hook up microphones or mixing desks to ipDTL on their computer. It's got line stroke microphone inputs on the front, which take a jack or an XLR. If we look at ipDTL, you'll see currently it's only registering on the left-hand side. Now that's because we're only plugged into channel 1. If we plug into channel 2, you'll see it now registers on channel 2. Now there's a simple fix for this. If we go to ipDTL's audio send mixer and click on LL or RR, then it sends a signal from one channel to both sides of ipDTL's audio stream. Looking at the front of the 2i2, we have 48-volt phantom power available, which is required for condenser microphones. We've got a headphone socket for zero latency monitoring of your local microphone, and indeed listening to the feed from your computer, including the incoming stream from ipDTL, and a level control for that. Onto the back of the Focusrite, the USB connector is in the middle, and we also have line outputs which you can connect to your mixing desk, for instance, your soundboard, and that's how we're going to hear the audio now from ipDTL's loopback server. So I'm going to click on loopback in ipDTL. What you're now hearing is the audio being sent to ipDTL's test server and coming back out through the back of the Focusrite device. Let's look next then at a handheld USB microphone. This is the Samson Q2U. It's towards the lower end of the market. It has a USB and XLR socket on the bottom, so you can use it as an analog mic. I'm going to connect the USB to the computer, make sure that the switch is turned on. We can see we've got USB power now, and before I go any further, I'll refresh the page in ipDTL so that ipDTL can see the microphone in its audio source drop-down. So I'm now going to change ipDTL's input source to the Samson Q2U microphone, and you'll see this one, because it's a mono microphone, immediately appears on both channels. So there's nothing to do in ipDTL's send mixer there. The thing you'll notice with the Q2U, if we connect a loopback test, so you're now hearing the audio from this handheld microphone going through ipDTL's server. It's quite susceptible to handling noise, so you've got to be very careful with that. Hold it with a good firm grip, or perhaps use a stand. For the price, it's great. It's ideal for portable use and radio contributions. One other thing to say about the Samson Q2U is the headphone socket on the bottom also allows zero latency monitoring and the incoming stream from ipDTL. Let's look next then at the blue Yeti. It's a bit of a beast. It's quite heavy construction with a good solid metal stand. On the bottom, it's also got zero latency monitoring for your headphones and a fairly flimsy USB socket. We'll pop that in the bottom. Be really careful not to yank on that because it will damage your microphone. On the front, you've got a headphone volume level, so you can adjust the incoming feed and indeed your monitoring. And if we look on the back, you'll see that we have a gain control, and you can switch between various polar patterns which affect which direction the audio is picked up from. Looking at ipDTL, again, we refresh the page so it appears in our list of options. And we select the Yeti microphone. The immediate thing you notice here is that the send level from the Yeti, even with the gain switched right down on the back, is particularly high. So I'm going to go into my Mac system preferences, take a look on the input tab at the Yeti, and bring it down some. I can also compensate in ipDTL's audio send mixer, but you really should start by adjusting it in the computer settings. Let's try the audio through ipDTL then. Clicking on loopback, this is the sound of the Yeti microphone being sent to ipDTL's test server and back. Here's a nice option if you're on the road. It's the somewhat portable Shure X2U XLR to USB adapter. It has a headphone socket for zero latency monitoring, and you can balance that level with that coming from the ipDTL stream. You also have a volume control for overall volume and a mic gain control. I've got the Beyerdynamic M58 microphone attached here, which is a workhorse for many journalists around the world. You'll see I've had to boost it a little here in ipDTL because the output from this mic through this device is fairly low. You can also add a little extra gain in here if required, but do save this as a last resort if you've tried all other options of increasing gain, both in the device and in the computer settings. So, onto the Rode NT USB. I'm going to try an ISDN connection in a moment, so I'll switch on the codec there. See what we've got in the box. Nice carrying case with some instructions inside. A stand for the microphone. A pop shield, which is great to be included as standard. And here's the microphone itself. Now, I should say that I'm spending more time on this microphone simply because it's the newest tool in our arsenal, not because we recommend it above the other devices. I'm going to attach the pop shield to the bottom of the microphone and then screw on the stand to the microphone's base. It feels fairly well built, and I should also make sure that the front of the microphone faces towards me and indeed the pop shield. Now this microphone stand, if you remove this section, it does actually turn into a normal mic clip that you could use on any other stand. So I'll position the mic facing slightly upwards. We'll just take a look at the controls on the side of the microphone. And you can see, a bit like the Shure X2U, you can balance the level between the mic itself and the incoming feed from the computer and ipDTL. And then for your zero latency monitoring and indeed the local monitoring, you've got a headphone socket here with an overall volume control. On the base of the mic, you've got a larger style USB socket. So we'll connect the USB there and then refresh ipDTL. So that now in our list of audio sources, we see the Rode NT USB. And I'm going to prime ipDTL to receive an incoming ISDN call to one of our lines in the UK. Give it a moment and it will present us with two numbers to dial. On my ISDN here, I'll switch the codec settings to match those of ipDTL, which in this instance are Layer 2, which is MPEG Layer 2, Mono 128. And indeed, we'll do the same for the return, Layer 2. We'll also match the sample rate, 48K. So let's try dialing the numbers on channel 1 and on channel 2. You see we have a lock, which means that the ISDN has framed. You'll see my voice level now appearing on the receive meter. Let's switch then to the output audio from the ISDN. So I'm talking to you now into the front of the Rode microphone. It's going into ipDTL, across the internet, onto the ISDN network, and you're now hearing it from the back of the Telos unit. Let's just try popping a reflection filter behind the back of the microphone because we're in quite a reverberant space here. You should see that that makes a bit of a difference to the audio quality. Thanks for watching.